IntelliQvic tutorial number 2, how to import a DXF file and prepare it for the wire EDM. So we have some class examples that we use in the wire training class, so I'm going to show you how you can import those DXF files. So first step, we'll go to the model page. On the model page, use this pull down where it says pattern and select 2D file insert, and then hit this folder icon. By default, if you hit the folder icon without selecting 2D file insert, that'll be for importing parasolids. So we'll hit this, and I already have the files transferred into the machine, and the software will be looking at the proper folder where the machine copies them into. But I'm on the desktop version of the software, so it's a little bit different than the machine version. But the first step you would need to do is copy the file over to the machine. Since that's already done, we can see our files are here, Class A, B, C, D. So we're going to open these files. So we'll have to, in the class, we would show you how to put the file into the machine first at the machine, on the file page at the machine, transfer it into the machine off your USB stick, or you would transfer it through the network if you have your network connected, because you have to transfer it to the machine first. So now I have them in the machine, let's say, and I'm going to open Class A. So I select it, hit open. Oop, there we go. And it opens up on the screen. So there's my geometry, little square. Let me go File New. Let me just do that again. 2D file insert. I think I clicked on the wrong one. Let me sort by name. I had it sorted funny. Class A. So there we go. That's Class A, just a little square. All right, so it's green colored now. So if you close the window and just click in the screen somewhere, it'll go back to green. So that was the active. It goes back to black from the green. The green was like an active color, and black is your normal geometry color. So there's a few colors. I'll point them out as we go along. So let's do that again. File New to clear out what I have. And Model, 2D file insert, folder button. Let's open Class B. That's the little L shape. And File New to clear it. And let's open the other one. Make sure they're all there. Let's make sure they all open. Class C, open. So these are our 3 little cuts that we make in the class, the training class. We punch in a die shape for these 3 shapes, and if there's time, we have a couple other ones that we will make also. But I want to go through these 3 main ones first. They're all kind of similar how you would go about preparing the wire program for them. But there's some things I want to teach as we go along. So I used File New to clear out the screen. You can use that. There's also this delete button here. So if we notice here, I can select the model, and then I could, if I wanted to just clear it, I could hit the delete button to delete the model. Sometimes you import a parasolid and there's more than one model from what you've imported, so that they'll be listed here in this list, and you can delete out the ones you really don't need if you're not programming them to get them off the screen. So that works kind of like File New, clears out the screen. When you bring in a DXF, it's just that one model. So let's open one up and we'll make a program. 2D file insert, folder icon, Class A, open. So there's our little square, ISO view. See, it's pretty flat. Top view. So first step is place model. When you import your file, if you prepared it in the CAD software you're using for 0, 0 to be in the correct spot for where you're going to pick up the part with the wire machine, you should be ready to go. Sometimes another engineer is programming the part and puts your part out in space or someplace so it just prints out nice on a piece of paper. So we need to use place model to put the origin somewhere we're going to pick up on with the wire machine, or put it in the center of the geometry, something like that. So I'll show you how this works. Place model. So we have our model reference here, so make sure which model you're working on. Like I said, sometimes a solid will come in with several models, so make sure you're working on the proper one here. Your model reference point. So now this is if you have something on the geometry you want the origin to snap to, let's say. You would use, if you don't know where you want to type them in, you can type in an X and Y number here. And I know this is like a 2-inch square, so I could type a number, but let's use this function here with the arrow. I can click that and see how it snaps to that corner. I get a little icon. I can click that, and the numbers automatically feed in, and I can hit define. So that sets a reference point. So that's step 1 of doing this. And now I can move, and this little icon here is move to the reference point that you just set. That's what this does. Or there's several things you can use in the pattern, but let's just stick with move for right now. Let's move to the reference point, see our preview, and then you hit define. So now our origin is set at the corner of the block. So we would do maybe a corner pickup with the wire machine to set this as 0, 0, and then our program would move from there into the shape and cut it. All right, so let's just put it back. I'm going to put it back for where we had it. I'm just going to do File New and reopen it. Model, 2D file insert, Class A. There's Class A. So what I want to do is I want to put, in this case, we just want to put it in the center because we're going to make a simple program to cut this out in a block of steel. So we will put the origin there. So I need something here to snap to. I need a circle or something like that. So we're going to go to 2D drawing, 2D drawing, and I'm going to just put a circle there. I'll pick this third one down from the top of the blue circles. It's going to ask me for a radius. I'm going to put in 20 thousandths just so a number, hit return. And then I'm going to say, where do I want? Now I could snap. See, this gives me these yellow lines. I could snap to that. And then what I would want to do, so now I would want to check that. So hit this blue button to get out of the drawing mode. And measurement, attribute, and let's make sure it's in the right spot. So if we check this element, it's Y2, I believe, or Y1.8. X2 is this element, and X over here is 0. So, oops, measurement, attribute. So I want this to be, so it's at X1 and Y1. That looks correct to me. Next step is to move the shape there. So let's place model. Model reference point. We're going to select that circle. Define. In the place, we hit the origin and hit define. So that moved our shape. So if we check again, measurement, attribute, let's just check it. This element, Y1.2 or 0.125. This element minus 125. This element X is 125. And this element is minus, so I got it on center. So just wanted to check that. So first step, like I showed you, was to bring in your model or your DXF file. Second step is place the origin where you want it. Third step is to put a start hole in. We have a circle, then we need to convert that circle into a start hole. So in 2D drawing, there is start hole. Choose that. And we know 0, 0 is where we want it. So I can just leave this filled in. I don't really have to do anything but just hit the new button. And it'll put a start hole here at 0, 0. So why did I do that? So this had a circle there. Seems like we could use a circle. What you have to do is have an actual circles are geometry that you can maybe wire cut, and start holes are for the tool path to start from for your lead in line. So there's two unique differences between them. That both are circles, yeah, but we need a start hole. We need to define a start hole to be able to make a machining path, tool path. Okay, so we have that ready to go. Next step from here is we were over here. We want to go next to machining path and path generation. Oop, I'm sorry, not machine. I'm sorry, I mistake. Feature recognition, contour. We want to make a feature recognition contour extraction. I skipped ahead for a moment. Sorry about that. So this is going to find what we want to wire cut. So now we want to just wire cut this inside piece. So I'm going to put in a table of program here. This is going to be my block thickness. When we do taper, this becomes a little bit more important to set properly. When there's no taper, it's not too important. It's just going to show it to you at this thickness as a solid after we do this step. So I'm going to make a die. I'm going to set my extract pattern to die. And the start element, I'm just going to pick anywhere on this square. And then you hit extract. And then it finds that square. So let me do that one more time. Let me go into delete contour page. And we're back to geometry. Feature recognition, contour extraction, table of program, 1 inch. I think the class blocks are 875 to be 0.875 to be a little bit more exact. Now, if I left this thing on all, if you just leave it at the defaults, like I open this menu up and that's the default, it's on all. If I just do that and hit extract, you're going to get 3 of them. One for the inside, the one we want. One for the outside, that would be like a punch cut or a die cut. And then the circle. Remember I drew a little circle in there, so it thinks I want to maybe wire cut that. So see, I got 3 of them here that I really just want the one. So I can delete them here. There's a button. The ones that I don't want, I could have just left it on all and then just delete out the ones I want. It's fine if they're there. Because when you move on the machining path, you can choose which one you want to cut. You can select all of them to cut all of them or just choose which one. I like to get rid of them. So there's a couple ways to get rid of them. You can select them here and hit the delete key. Or you can go into feature recognition and there's a delete contour choice here. And this is a little, if you have a whole bunch of them you need to get rid of, this is a little bit better way of doing it because you can hit select all. And maybe gave you 3 or maybe 5 or 6 or something of them, and you only want one, so you can select all and then uncheck the one you want to keep and hit delete. That's a little faster if you get a whole bunch of them. Now, another way, the more proper way to do this step, let me get rid of that. Like I said before, is to go into here, contour extraction, set it to punch or die, whichever you want, or open shape. Set your program, 0.870, if you're going to put that back in. And the element, click somewhere on the shape that you want to cut, and then hit extract, because then you'll just get the one. Okay, next step is machining path, path generation. See, the one is here, only one, and it'll be check marked. The first one will be check marked. If you had more contours, this is where I was saying you could uncheck the ones you don't want to program. And we'll talk about this automatic generation in a little bit. But I'll make show you how it works normally. Hit generate, hit the conditions, Now you should have already been trained a little bit on what this condition menu is on the machine. You're going to fill this condition search menu like you would if you were at the machine. We kind of should have talked about this already in the class. So I'll put this to a close flushing and maybe 2 cuts. And I want the corner controls turned on. Now, this confusing menu, what we want to concern ourselves with is the right side, where we have the residual stock. Starting cut under the machine settings there. We have a direction to go, a starting cut length. This should be a value that's a little smaller than your lead-in line. Recommended. That's one way to set it. Or, I mean, it could be a bigger number than that, but I usually set it at some value like 90% of the lead-in line. Your residual stock is going to be your glue tab distance. So that's going to be the hold on. On a die shape, it's going to stop short a little bit. And then you are there to hit the go button and cut the last little 50 thousandths off. Let's say I'm going to set it at 50. And then you have to pull the slug out, and then she does the skim. Okay, and then the avoidance is the little retract move off of the shape. After each cut, it cuts around and it retracts off the face to cancel that offset. So that needs to be a little number, not too big, just to get it off the face of the part. Okay, so let's do that for now. And it says specify the starting hole. We click our starting hole we made earlier. And next step would be to select the entry face. It says select entry element. So we will select this face, and we get our tool path. We put on top view, so you can see your yellow tool path with the little blue. That's your stop distance, and this is the distance it retracts. So those two distances, let's go in here and let's turn on path correction. Those are these two distances here, residual stock and avoidance. Okay, so when you set your tool path up, let me zoom up on that, you need to set those up similarly. Your starting cut length is going to vary based on how big of the part is. You want that to be your lead-in line length, a little less than that usually. You've got probably at least 1/8 of an inch long lead-in line. I would think you probably have a 1/4 inch, and maybe leave this set to like 1/8 of an inch then. These wire class samples are pretty small, so you want to watch the size we use here. And you leave this on residual stock, and then this will be the tab length, and this will be the pull-off move. And I'll hit OK. And now notice I'm in correct path, so it says specify the start hole again and specify the entry element. So I'll put it at 12 o'clock this time. And it goes up towards 12 o'clock. Okay, so let me do this one more time. And in the machining path, I may choose path correction. And I'll select the tool path here up in the top left. And this time I'll choose automatic. I'll show you what that does. Path correction. I'm not going to really do anything in here to correct the path. I'm just going to say OK. And automatically, I didn't have to pick the start hole and the lead-in line. So that button that I used to generate automatic, it makes it pick up the start hole, find it on its own. Okay, next step would be to create the NC code for the wire machine. So you go to NC conversion, convert to NC, put a name in for the NC file name, Class A. Use no spaces in the name. And this time we want to look at convert parameters real quick. This is the way I configure my, the way I like to configure it. Stop before the cutoff, so it'll be the M00 to stop the machine. And once you hit the go button to cut the slug off, you're usually standing there to be able to remove the slug. So I usually say no to the cutoff, stop after the cutoff. If you plan on having big cutoffs and you're going to walk away from the machine, then put this back to, pull this down to say M00. And I use condition of the cutoff can be either, C1 T84 or C0 T84 is a little safer from keeping the wire from breaking at the little cutoff there. And and also the pull down here. I'll stop after the cutoff. You have your M00. I also set move to the first starting hole and output in a single coordinate system check mark and no check mark on subprogram. So basically it writes a program top to bottom without subprograms, which is easier to read. And move this first starting hole. This will be your choice. What that will be is it'll give you, if you have it turned off, you'll get a G92 at the beginning of the program of your X and Y start point coordinates. So in other words, you have to have the wire machine in position when you hit the go button, because it's going to start from wherever you place the machine. It's going to start cutting from right there, that shape. Whereas if you have a M00 or a move to first start hole, it'll move the machine to the start hole. If you're away from the start hole, it'll move it there. For the wire class, it's easiest to maybe leave that off, and because we don't really care where in the block you start, so you usually just put it in on a hole that's in the test cut block, this class blocks, and start, you know, at a random spot in that block. We're not worried about being in a position exactly, so that will work good for class. When you get back, you probably want to have this on move to first starting hole. That way, if you jog the machine away and hit the go button, it'll move itself back. All right, and then you just hit the convert button. So that'll make a program, stick it in the memory of the machine, and then you use the machine's graphics to draw the simulation. The software on the machine, the IntelliQvic does not do simulation. You use the machine side for that, and being I'm not attached to a machine here, I can't really do a simulation. So next step would be at the machine, and you would go to the edit page and then hit graphic and draw at the bottom. There's a draw button, and it'll show you a simulation of the wire path that you just created. So I'll close this down and exit out of here, and I made a program here. It's sitting in my NC program folder. Let's see if I can find it here. Here we go. Class A. Let me just open that. So here is your Class A NC program that it just made with the cutting conditions. So in class we explained how this works, this program. It has your power settings and your offsets here at the top, and then from the G90 down is the actual program you made. So the header is this C0 and H codes here. That's your wire comps and your power codes. And then the program you just made is here from here down. So that's first class example.